Optimization can be regarded as a special case of a parameterization because parameters changes are realized using a selected algorithm with the goal to find the best possible solution of the problem. As the quality of the solution is important in this case, the definition of what is a good result or what is not has to be given. This is usually realized by a definition of a corresponding criterion function. In the area of mathematical modeling, it is frequently desired to select one or more models parameters in a way that using the same input signal to the real system and to the mathematical model, both responses would be as similar as possible. This problem is presented with the block diagram in this figure. Let's illustrate how it is possible to solve such an optimization problem using MATLAB and Simulink. Suppose the system is in this case known and defined with the equation 2.13. The structure of the corresponding system was estimated correctly together with two parameters as is presented with the equation 2.14. The goal of the optimization is, in this case, to find the corresponding values of the parameters a1, a2, b1, and b2 so that both responses, that is, the one of the system and of the model, are as similar as possible. The similarity will be measured with the integral criterion as is defined with the equation 2.15. Solving this problem demands a definition of three files. The first one is a simulation model. We have built simulation model SimModel5 SLX, which is an equivalent to previously presented block diagram. The second file we have to develop is the script-m file, namely myfile5.m, where all needed data is defined. First, parameters under investigation are defined as global variables because Simulink is using this information during simulation runs. Regarding the optimization method we are going to use, also initial values for the parameters which will be optimized have to be defined. Let's open the figure next for the results presentation. Such presentation takes time but is illustrative. With the function optimSet, the optimization parameters are chosen. In our case, two input parameters are defined: tolerance value of the result and tolerance value of the criterion function. Use the command help optimSet for further information regarding different possibilities which are influencing the optimization procedure. Now it is possible to call an optimization function. In this case, the MATLAB function fminsearch was chosen, which uses the Nailor-Mead simplex method, which is a direct search optimization method. Additional possibilities are available in two toolboxes, in the Optimization toolbox and in Global Optimization toolbox. The input parameters to the fminsearch function are in this case myfile5a, which is the name of the criterion function, initial values of the parameters, and defined optimization parameters. The outputs are optimized parameters and the corresponding value of the criterion function. When the optimization procedure is finished, optimal parameters are displayed in the MATLAB command window. Responses of the final result are plotted again. Then also figure 2 is generated. Here, used input signal is plotted first. And finally, also the system response with blue circles and the response of the optimal model with the red line. Criterion function, namely myfile5a.m, consists of the following lines. First, global parameters are defined. Then, temporary values of the optimized parameters are given to the A1, A2, B1 and B2, and simulation run of the file simmodel5 is started. At the end of the simulation run, the criterion function is evaluated at the end of the simulation run, and system response is plotted with blue circles, while model response is plotted with the red line. Let's observe now the consequences of the execution of the prepared files. I'm starting the file myfile5, and here we can observe the temporary results. Here we have the final result, and here also the input signal is presented in addition to both system responses. It is important to mention that in this case the optimized structure was correctly estimated and initial parameters were suitably chosen. Homework number 1. Repeat the optimization for the situation as is illustrated in this figure. Here the order of the model is lower than the order of the system. Analyze and comment the obtained result. Homework number 2. Repeat the optimization for the situation as is illustrated in this figure. Here, the order of the model is higher than the order of the system. Analyze and comment the obtained result.